This is a video record for homework A, problem 2. The problem setting is let n be a Poisson process with a parameter lambda, and the probability of this process can be written as P equal P bracket n is the number of random points arrive in T1 to T2 in the interval of T1 from T1 to T2 is equal to K. And so it can be written as it can be written to be equal to e to the degree of minus lambda times t the sum of T2 plus minus T1 and the times K exclamation mark over lambda times T2 minus T1, and the product is to the degree of K. So we define this stochastic process as as the graph shows, where xt is equal to 1 when the n in the interval of from 0 to t is equal to is an odd number, and xt is equal to -1 if n is even in the interval from 0 to t. The first equation is ask us to find out the the probability of xt equal to 1, and this is an incident where n is odd in 0 to t, and this can be written exactly as e to the degree of minus lambda t times lambda t to the degree of k over k exclamation mark. This is exactly substituting 0 and t to be t1 and t2. And for the second question, we have to find out the means of x of t. It is exactly e of xt. And so, as we know, this is a Poisson process, and we can rewrite this, and we can get the integral or the sum of the process on the interval from the interval 0 to actually infinity is equal to 1. And during this process, we can rewrite this equation into this form, where we multiply this term on both sides of this equation, and then we take the derivative on both sides of lambda. I'm sorry. Take the derivative of lambda on both sides, and we can get the left hand side of the equation is equal to this, and the right hand side of the equation is equal to this. Then we after taking the derivative, we can get a term as k and t on either side of this equation, and we try to make this term to be of the same degree as the right hand side. So we times lambda on both sides of this equation, and we can get and also we can get if we divide this term back on both sides, we can get it back in the left hand side to be like this: k times e to the degree of minus lambda t times lambda t to the degree of k over k exclamation mark is equal to lambda t. And the left hand side of this equation is exactly the definition of e of xt, which is equal to this term, and thus we get it to be the e of xt is equal to lambda t. This is supposed to be a constant value if t is a constant. And for the third question, we need to find out the relation function of T1 and T2, and we rewrite it as e of xt1 and times the xt2 reverse, and we can actually no, this is correct. It is equal to e to the e of xt1 times xt2, and this can be rewritten as by adding a certain term minus this term xt1, and also adding this term plus xt1. We can write this equation to be xt1 times the e of xt1 times the e of xt2 minus xt1 plus the term where xt1 is solely existent. It is e to the e of xt1 to the degree of 2. This is actually equal to this, as we know, this term is e of xt1 is lambda t1, and these two terms are essentially the same. We get the value to be lambda t2 minus lambda t1, and the product of these two terms plus a term that is f1 plus lambda t1, and the sum times lambda t1. This is get from finding the value of e of xt1 square, and this equation is exactly equal to lambda times t1 plus lambda t1 t2. This is the final result for the relation function. And the fourth problem asks us if xt is WSS, and we know that this is xt is not WSS, because e of xt is equal to lambda t is a constant, but the value of rt1 and t2 is not a single function which is only dependent on the difference of t1 and t2, because this can be written as lambda t1 times 1 plus a lambda t2. This is not a term where we can rewrite it as something that is solely dependable on the difference of t1 and t2. So xt is not WSS. This is the end of this video record.